These are lakes under the sea.
And they're so toxic that they kill anything that wanders into them.
They look similar to lakes on land as they have visible shorelines, rippling surfaces, and even internal wave-like motion at their boundaries. Underwater lakes exist because of extreme differences in salinity and density between normal seawater and highly concentrated saltwater, which is known as brine. Because density increases with salinity, the resulting brine sinks and accumulates in depressions on the seabed rather than mixing freely with the ocean above. Although it involves a different process, it's a bit like how oil floats on water. The light seawater remains above the denser brine, forming a stable layered system. Also, geologically, many of these features are linked to the presence of salt tectonics. Thick underground salt deposits, often formed millions of years ago when ancient seas evaporated, can become buried beneath layers of sediment. Over time, the salt behaves plastically under pressure and can migrate upwards, forming structures such as domes or ridges beneath the seabed. These structures can fracture overlying rocks, allowing fluids to move through them. Some underwater lakes are associated with cold seep systems, which is where fluids rich in dissolved minerals and hydrocarbons escape from deeper geological formations. In these settings, brine may carry methane or hydrogen sulfide,
which are highly toxic.
The chemical composition of these pools can be so extreme that they become inhospitable to most marine life, although specialized microorganisms are sometimes able to survive at the interface between the brine and the seawater. Once formed, submarine lakes can persist for long periods because of the limited turbulence at that depth and the strength of the density gradient between the layers. Ocean currents can flow over them without disrupting the boundary, allowing the brine to remain trapped in place. So, there are lakes beneath the sea. They are a product of geology, chemistry, and fluid physics working together. There are also complex and layered environments that we might not expect.